Hello everyone. Today we're going to talk about backtracking, one of the most powerful techniques in problem solving. Mostly we implement backtracking by using recursive functions. So before jumping into code, let's clarify two very important ideas. First things first, permutation is the technique that we already gone through in the previous videos. So for example, 1, 2, 3, and 3, 2, 1 is the even if they have the same numbers, but they uh, considered as different cases. So in the permutation perspective, the order really matters. But on the other hand, combination order does not matter at all. For example, 1, 2, 3, 3, 2, 1, or 3, 2, 1, 1, 1, 3, 2, whatever it is, it has the number of 3, 1, 2, 3 anyway. So we consider those three or more kind of cases as one single case. So this is all about the explanation about permutation and combination. So let's jump into the first example for today. Well, in the example over here, where you choose three numbers from the range 1 to 4, which has the three levels and four branches, we can classify the problem into four different cases based on permutations and combinations, as you can see. For each concept, there are two variations, that one that allows duplicate numbers and another that prevents duplicates using a visited array, which is pruning. So in the case of permutations, the order of numbers matters. So at every level of recursion, we can freely choose any number in the range, depending on whether duplicates are allowed or not. But combinations, however, works a little differently. Since the order does not matter, we must prevent generating the same set of numbers in different orders. To achieve these, the number selected at the current step must not be smaller than the previously selected number. In other words, the sequence must always be non-decreasing. For example, if we choose 1 and 1, we're allowed to 1, 2, 3, 4 in this case because the 1 is minimum number anyway in among this range. But when it comes to 2, when we choose 2 in level 1, in level from level 2 we have the restriction. We cannot choose 1 again, which is smaller than number 2. So we're allowed to choose 2 or bigger numbers like this. With the same concept as well, if we choose 3 in level 1, we're not allowed to choose 1 or 2 in level 2. So this is how combinations order works. So that's why for combinations, I plan to add an extra parameter called start to the recursive function. This parameter represents the minimum value that can be chosen at the current level. By doing this, we can naturally avoid duplicate combinations without using a visited array as well. But there are four different kinds of cases as well, using the visited array or without using a visited array as well. So now let's move on to the coding part. Well, I'm gonna show you the permutation without using a visited array first. This is kind of basic example that I already gone through in the previous videos. We start from level 0 all the time. So if level is 3, I'm going to return it. Before I do that, I'm going to print out the pass array. I'm going to make the pass array with character type. We have four different kind of choices from 1 to 4, and I'm going to mark pass like this. When I come back, I'm going to erase it. So this is kind of basic code. If I execute this file, as you can see, this is how the permutation works without using the visited array. So the same numbers in one case are allowed. So there we go. And I'm gonna throw in the visited array to prevent the same numbers choices. When we come back, I'm gonna erase it. So as you can see, 111, 112, or whatever it is, they have the same number, so it should start from 1 to 3 in the permutation. But it can the permutation pattern as well, because they consider 1 to 3 and 2 on 3 as a different case. So it is allowed to this kind of pattern is allowed in the permutation. But like I said before, the combination is a little bit different. I'm going to show you the combination without using the visited array in this case. We need the start parameter, and we start from 1. We need to fix this part. We need to throw in t in this case. So if I execute this file, well, as you can see, yeah, the same numbers in one case are allowed in the combination pattern, but as you can see, um, if 112 is already you know chosen, then 121 is not chosen in this case. It starts from 1 to 2 right away. So this is how combination pattern works. And lastly, if I throw in the visited technique to prevent the same choices, it has only 4 different kind of cases. There we go. Let's say you are in the final round of Master Chef. You must choose 3 different ingredients from the pantry. So you cannot use the same ingredient twice. So that's why we have to use the visited array in this example. And rule number 2 is that cooking order changes the taste. So the order really matters. So we're going to use the permutation, not the combination. And rule number 3 is your goal is to maximize the total flavor score. And the later you add an ingredient, the stronger its impact on the final dish. So this is how we get the final score. And so if I draw the tree-shaped structure, we have 4 branches and 3 levels. We have ingredients A, B, C, D, as you can see. I'm not going to write it. I'm going to write the flavor score instead. 7, 2, 9, 3. Well, if I anticipate the final result of this code, it must be, we have to choose 3 to maximize the total score in the first choice, and which is D, ingredient D, and we have the second choice as well. We have to choose 7, which is the second largest, which is A, and then we have the last choice, and we have to pick up 9, which is ingredient C, to maximize our total score. So if I calculate the final score, it must be 3 add 14 add 27. So it must be 3, 14, it will be 17, and this is 27. The final score must be 44 with the choice of D, A, C. There we go. Well, first things first, I'm gonna write down the basic code first. Well, we have the flavor score with 4 different kinds of score, which is 7 with ingredient A, 2 with ingredient B, 9 with ingredient C, and 3 with ingredient D. So there we go. We need the level and sum with the parameter of our recursive function. I throw in 0 and 0, and we need to set the maximum number with the smallest number that we can represent. And we have 3 choices. We go deep down until level 3, and I have to update the value of maximum. If some value is larger than the maximum number, I'm gonna update the maximum number. There we go. And we have 4 different kind of choices, like I said before. Well, I need the visited array as well. Size of 4. And I need to calculate the next score. Next score would be flavor key multiply level at 1. There we go. And then we're gonna add the current sum value with the next score value to get the final score. And if we come back, I'm gonna erase the visited array. There we go. And then if I print out the final score, final maximum score, it must be 44, like I said before. As you can see. Well, on top of that, we really want to figure out how we get this maximum score. So we need the path array. So I need the path array with the character type. Path with size of 4, because we have to consider the null character, and we need the path with size of 3 because there are 3 choices. And I need the max path with size of 4 and max path with the integer type as well. So I'm gonna write down the path, the marked up path with the value of what we selected for our flavor score. There we go. And then we have to mark the character path as well. There are ingredients from A to D, so this is how we mark the path array. And we come back, we have to erase it. There we go. And then when we meet the maximum update point, we have to update with the final results array, which is character max path, and goes like this. Size of character multiply 4, sorry. And then in this case, we need to copy the value of the score to the next pass, the normal pass. There we go. To use this kind of function, memory copy, we need to include C string, and yeah, and I'm gonna print out the value of the pass. It must be next pass. Need a space. Flavor score course. And I'm gonna print out the ingredients choices. There we go. As you can see, the flavor score choices is 3, 7, 9, as we expected, and the ingredients choices is DAC with this order, DAC. And the final maximum score, like I said before, it must be 44. So yeah, exactly same compared to what we expected already. Let's say you're a scientist in a virus lab. Each cell in a 3 by 3 grid contains a virus level. A virus spreads through 3 fixed levels from level 0 to 2, and at each level, it can choose one of 9 branches to mutate over here. And every time an injection hits, the virus level is recalculated using the strict rule over here, and it affects the 4 adjacent cells, but not the selected cells. And so, although the structure looks recursive, the limited scale, 3 levels and 9 branches, means the entire simulation can be handled with just a double for loop over here. And so, the real danger lies in memory. Once an array is passed as a parameter, it behaves like a pointer and directly alters the original data. Because arrays cannot automatically restore themselves like normal variables, so a backup array is mandatory before each mutation. As a result, keeping arrays as local variables offers no real benefit. The original array should remain globally, while backup arrays are managed inside of the recursive function to guarantee safe recovery. And I'm gonna show you over here by choosing the random cells and show you how the mutation works for the final result. Well, in order to show you the example first, I'm gonna pick up the, the random cells first. And so, just so you know, I'm gonna follow this strict rules. And if I select these cells randomly, it will affect 4 ways like this. So it's gonna be this part is not gonna change, but this part must be 6, 4, 2, and 8. And if I select this part, it will affect 2 ways like this. So the rest of them just remain unchanged, but this number is gonna be 2 and 6. And what about this cells? If I choose this cell, it will affect 3 ways like this. So 2, 8, 6 to 9, and that's going to be 0, 4, and 2. and over here must be 4. There we go. So if I calculate, if I add up all these 4 numbers, it must be um, this must be 12, and this last row must be 15. So if I add up this number, it must be 37 with the random selection. But it does not guarantee the minimum result because I choose the random cells anyway. So to be certain, we must write a program that explores every possible choice under the given rows. So only after running the algorithm can we confirm what the true minimum value actually is. So let's move on to the coding part. Well, first things first, I'm gonna write down the basic code first. Well, I need the C string to use the memory copy for the backup array. And well, I'm gonna call the recursive function over here. And we need the 3x3 grid 5, 3, 8, 2, 6, 4, 7, 1, 9 is the the initial value of the virus level, and the recursive function has only one parameter, and if level hits 3, I'm gonna return it. But before I do that, I'm gonna check the value of minimum value versus the value of the sum as well. So if the return value is smaller than minimum value, I'm gonna change the minimum value like this. And yeah, minimum value should be set with the very high value to trigger this kind of transition. And I need to get some function as well. And this is how we get the sum value from 3x3 grid. There we go. And then, yeah, like I said before, we have 9 different kind of branches, but we can make the double for loop to represent that 9 branches. So before we get into the branch, we need a backup array. We need to restore the original lab array value first. Three by three, and need to mutate the lab, and I'm going to throw in some coordinates, and then we get into the next level. And if we come back, I'm gonna restore the lab array with the backup array again. And yeah, maybe we have to complete the mutate related function. It has 3 different kinds of parameter, and we need the direct array as well for the 4 different kind of ways. There we go. And then we have 4 ways, like I said before. I need to take care of the boundary condition to prevent the index overflow or underflow. There we go. Then the adjacent cells will be affected by this um, this rule. So multiply 2 and 10. There we go. And yeah, I think this is all about the coding part. And if I print out the value of minimum value, it says 30, not like 37. Well, to figure out how we get the value of 30 as a minimum value, we need the structure first to contain the coordinate and maybe value as well. We need the path array as well, node path with the size of 3 because we have level 3. We have 3 choices, I mean, and maybe I need to set the breakpoint over here. And I need to mark the information before it changes the value of the lab array. And I'm gonna mark the information, and when we come back, I'm gonna erase it with 0. And yeah, if I execute this file again, well, the first minimum value is 50, but if I go over and over, it is 30. And so yeah, this is how we get the minimum value of 30, and I'm gonna track down this coordinate over and over and see the final result of the lab array. Well, it says at level 0, we select y value 0 and x value 1. So it says over here, we select this part, and affects 3 ways in this case. 0, 6, 2, and the rest of them do not change like this. And at level 1, we choose this part, and it affects 3 way as well. 0, 3, 2, 7, 1, and it must be 2, 4, and 8. And this cell isn't changed. And for the last choice, we select this cell to make the minimum virus level. 1, 2, 4, 0, 3, 2, and it's gonna be 8, 6, 4. Yeah, and then if I add up all these 9 different kind of numbers, 5, 14, 11, and if I add up these 3 numbers, it is 30. So this is how we get the minimum value of 30. There we go. So this is all about today's video, and I hope you find it very useful through this video. Thanks for watching, and see you on my next video. Bye guys.